Welcome back, everybody, to the Additive Snack podcast. I'm your host, Fabian Alefeld, and today we have a really awesome episode lined up for you today because we are talking about the Navy, we're talking about the Maritime Industrial Base, and we're talking about BlueForge, and therefore the BlueForge Alliance with Chris Holshouser. Chris is the Deputy Program Director Maritime Systems at the BlueForge Alliance, and therefore plays a key role in supporting the U.S. Navy's ambitious goal of 1+2. What that means, we'll talk about in a second, but overall you can expect a really awesome episode and conversation with Chris, where we'll talk about the growing pains of the current supply chain to the Maritime Industrial Base. We'll talk about why certain conventional manufacturing technologies aren't able to keep up with the current demand, how additive manufacturing can be one of the solutions. And also we'll talk about workforce development and how all of us can support that very important goal of 1+2 that we'll demystify in a second. So therefore, without any further ado, Chris, welcome to Additive Snack.
Yeah, thanks for having me, Fabian.
All right, Chris, before we click record, I checked we've had our first conversations back in 2020. You've been in the additive manufacturing industry for a pretty long time, and now at BlueForge. Could you maybe give us an overview of who is the BlueForge Alliance, and then how did you find your way into that organization, and just in general, how has your additive manufacturing journey been like?
Yeah, absolutely. So, BlueForge Alliance is a non-for-profit 501c3 that was stood up about 2.5 years ago. And really, it was trying to bring a creative approach to some very complex problems. So, being able to be a little bit non-traditional in how we address things like an entire supply chain for the maritime industrial base is really the intent of why BlueForge was founded. I over my career have been in additive for at least, let's say, 15 years or so, 20 years doing technology transition. And what really drew me to BlueForge Alliance was the impact that we're trying to make on such a national imperative. We know that, again, the mission of 1+2 and the ability to have BFA come in and galvanize the defense industrial base, really driving capability, capacity, and resilience through things like advanced technologies such as additive manufacturing. We also touch on supply chain optimization and workforce development, as you alluded to. So it's really that mission and that impact that we, as a collective, as a community, wake up every day and know that we can make such a difference, really was a selling point and continues to be a selling point for myself and everyone that we bring into the BlueForge Alliance kind of home. We have several partners, over 400 projects that really seek to drive, change in how we manufacture in the United States. And that's always been a passion of mine ever since the Manufacturing USA Institutes were stood up. This idea of bringing manufacturing back to the United States was something that's always driven me. And this is sort of the next step in my journey, is to be able to bring that at a national scale and sometimes a global scale when you look at some of our international partners.
Yeah, it's certainly a mission that's exciting to be a part of. I think it's an ambitious target and goal, but it's also awesome to see that the initiatives that are being driven are bearing fruit. Before we go way deep into additive manufacturing and the role it plays, could you maybe take us one step higher to that mysterious 1+2 strategy? What does that mean, and what is the importance of that initiative?
Yeah, absolutely. So the U.S. has a 3-sided military force structure, something known as the Triad, that makes up our nuclear defense. This consists of land launch missile capabilities, our submarines, and our strategic aircraft. And our adversaries have the ability really to locate 2 of the 3 of those, which makes our submarines one of our strongest deterrents to potential threats. So when you hear the term 1+2, we talk about 1 Columbia-class submarine and 2 Virginia-class submarines. And so those are kind of the 1-2 punch that makes up that submarine portion of the Triad. So what we found is that with the Ohio class starting to age in its life and starting to become to end of life, we recognize, thanks to the Davidson window, that there's some importance to be able to bring the Columbia class forward in its schedule. And this has been quite difficult because, as you can imagine, it's not easy to just build an entire new shipyard to meet this new demand. So we really have to work with the infrastructure and, in some cases, the workforce that we have today. So the 1+2 mission really focuses on being able to strengthen the supply chain that we have, bring in non-traditional manufacturers, and cultivate a highly skilled workforce, in which technology plays a huge kind of role in that and drives resiliency, scalability, and the ability to just make the hands that we do have available more productive, more efficient.
Gotcha. Okay, so that means that Columbia class is a new class of submarines that we haven't built before. We pulled the timeline forward, and we want to accelerate the production of the Virginia class submarines, which are already an established program. Is that correct? Or is Virginia also a new class?
No, that's correct. The Virginia class is being produced today, and the Columbia class we're trying to again accelerate so we can get the first ships in the water.
Gotcha. Okay. And as far as I understand, that acceleration and moving the timeline forward put a very big strain on the existing supply chain. Before we go into what role additive can play, can you give us a better idea on how this current or previous supply chain was set up? What type of organizations were playing a part of it, and why is it such a struggle to ramp up the capacity so rapidly?
I think what we started to see as BlueForge was being founded was that the industrial base as a whole was starting to become a little bit more fragmented and was using technologies like forgings and castings, a lot of welding that don't have a lot of demand outside of shipbuilding. And so you can imagine that we're somewhat stuck in time with those capabilities, and we cannot completely move away from them. They are the foundation on how we build ships. It's just that there hasn't been a lot of efforts to modernize those. If you think about some of the modeling and simulation that we've tried to bring along as part of the additive community, there's a lot of opportunity to, again, modernize how we do traditional manufacturing. Additive, on the other hand, is a way of accelerating and complementing, not necessarily one for one replacing forgings and castings. So I like to use the analogy, when we all got microwaves in our kitchen, we didn't completely throw out our oven. It's sort of a 1-2 punch. So there are some large forgings and castings that we will always have to do in order to produce these vehicles, but we can help alleviate some of the backlog and some of the pressure that the forgers and casters see by, shifting to an alternative technology like additive.
Okay. So, I mean, it's an interesting point you made earlier, that by not having a lot of probably commercial shipbuilding demands, also the defense shipbuilding capacity and capability went away. And I'm guessing a lot of that shipbuilding went over to China for commercial shipyards, at least, which then really meant casting houses had no business and left or just closed up.
Yeah, and it's a little bit of a lost art. There are some that do it extremely well. I mean, we talk about supply chain not being able to meet the demand. They are still some of the best manufacturers in the world. It's just, again, it's an aging technology, and there's opportunity really to improve upon that and to bring, like I said, complementary technologies alongside it to be able to create kind of a force multiplier when it comes to throughput through our existing supply chain. And then the other element of that too is, if you think about around World War II, or we like to quote kind of when Top Gun came out, was the last instance where we had the ability to flex our manufacturing, say, away from automotive and into more of the defense world. We've lost a lot of that in the United States. And so when I previously talked about bringing manufacturing back to the United States, we're not in the same position we were then to be able to leverage a lot of infrastructure and assets to be able to shift production.
Yeah. If I remember some statistics correctly, I think back in the 50s and 60s, manufacturing was still, I think, around 40% of the US GDP. Now it's at, I think, 11. So that alone kind of tells you the loss of capabilities within the US. Okay, that's really helpful background. And now let's talk a bit about the additive initiative. So when did it become apparent that additive may be a solution to the lost casting and forging capabilities? And I'm sure there was also a lot of question marks around that, right? Do you know how that all kind of panned out?
I think it was a combination of a top-down strategic decision to say, hey, we are seeing in the Navy, we are seeing other industries, specifically commercially, getting a lot of benefits from moving to such a flexible and rapid response type manufacturing process as additive. And it was at that point where we recognized that the Navy, for example, hasn't really certified a new material in, decades. There are specifications and mill standards out that guide us on how to do that, but it's really been, again, sort of a lost art. At least this generation of engineers don't have a lot of experience bringing new materials and process combinations on board to be leveraged holistically across the entire supply chain. And so you really needed the, let's call it, blessing at the highest leadership to say, we are going to commit to this. And we know that there's going to be a lengthy time in order for us to certify these new processes and material combinations. But we think if we invest in it now, it'll time out perfectly when we really want to have a surge in demand kind of hit. So this was probably a decision made even before BlueForge Alliance was founded, and basically said we are gonna commit wholly to going down this path and being able to offer this up as a viable alternative manufacturing process.
Yeah. With all its opportunities and challenges, one of the challenges that I could definitely see, not only within the Navy but also within its suppliers, is adding a new manufacturing technology, kind of like you mentioned, is a change process, and people need to think differently, need to accept different approaches from time to time. How is the Navy and the supply base getting ready to adopt that new technology, and what type of hurdles are you seeing on the ground?
Yeah, I think there's a couple things to touch on there. The first thing that the Navy did was stand up an additive manufacturing center of excellence based in Danville, Virginia. And this was, again, to really map out and understand the end-to-end process for additive. So we spend a lot of time talking about the printers themselves and what the printer can do, but we really have to think about securing up the raw material and being able to manage and navigate the feedstock, which in a lot of cases is very different than what you would get in a traditional environment. And then there's an awful lot, as you know, that happens after the print or the build itself, right? So to be able to close the loop in one location that has the expertise necessary to kind of train and allow escalation points into the Navy, I think was a key first step in just saying, hey, we're going to completely embrace this and wrap our hands around just what the technology can and can't do. And what they started to do was to create technical data packages that really looked at the non-recurring engineering that we all know has to happen. If I'm going from like a blueprint, I've got to be able to digitize that. I've got to be able to make sure that I account for, uh, design for manufacturability, which is not necessarily changing the design of the part, but how I potentially would load it in the machine, how I would configure it, just so that I can still meet the intent, the form, fit, and function of that part. We do have lock designs, so we don't get the benefit of being able to design for additive, but we do have the ability, through our slicing and kind of pre-programming software, the understanding to be able to make sure that when we hit print, at the end of the day, we know what we're going to get in a reliable fashion. So the intent there was to, again, buy down some of the risk in adopting it and have that organization go through some of the trials and tribulations. And I think they've made it through hundreds of parts now at this point, across many different material types, so that when different part families become available or are needed by the shipbuilders, we've already worked through a lot of the process development piece so that we can jumpstart the response to that demand. So I think the AMCOE, as we call it, really was a good launching point. And what that organization also has been able to do in partnership with BlueForge and the certifying bodies in the Navy known as NAVCO5, where all the tech warrant holders, also in collaboration with the shipbuilders, Newport News, Huntington Ingalls, Newport News, as well as GD Electric Boat, they've been going out into a lot of print shops who have experience in, say, aerospace or other industries, these high criticality application type spaces who already got the quality systems, and they've begun to what we call activate or certify against the standards for the Navy, so that they can apply their knowledge now to shipbuilding and round out their portfolio of potential product offerings. I think one of the things that you had asked about was what are some of the pitfalls maybe that we're running into, or some of the hurdles. Is you'll go into some of these shops who know additive inside and out, but they've got dedicated machines depending on what industry they print in. And this goes back to kind of a lack of a holistic standard that is consistent. We've seen organizations like AWS D20 as being somewhat consistent with what the Navy wants, but there's definitely some gaps in that qualification process. So we don't really have one standard that we can say, hey, if I certify my machine against the standard, then I'm good for aerospace, oil and gas, Navy, et cetera, right? And so one of the things that I would like to see us do next is to really drive some commonality, so we don't make it so complicated and difficult to qualify, dequalify, because I have to shift based on product kind of mixture and demand, and then to go back through a lengthy qualification so that I could be ready for the Navy. I think that's an area that we can definitely improve upon. I would say the other thing that we run into, we have a kind of a matrix approach in how we've selected manufacturers to take on additive. So one thought is, hey, I have a manufacturing house that already has additive in-house, but maybe doesn't know how to work with the Navy in particular, or in their history. How do we teach them what it's like to be a Navy supplier? Conversely, we've got these forging and casting houses or other machining type of entities, suppliers out there that don't know additive, but they're very forward leaning. And so the way we've approached this is we've actually partnered between companies who know additive with existing suppliers who know the Navy. And that's been a really great combination, kind of a 1-2 punch, where we can transfer knowledge both ways. And now I'm building capacity kind of at a 2x rate.
Wow. Okay. So there's really a two-pronged approach, which is one, take existing additive manufacturing contract manufacturers, get them into the maritime industrial base to be a supplier. But then secondly, and probably more difficult, how do we get existing suppliers to become additive manufacturing suppliers,
right,
as a complementary technology to the existing capabilities?
And we've seen a lot of success because on the latter side, it does sound like a very daunting task. Like, how do I teach someone a new way of making their parts that they've always made? But they're very familiar with the kind of the materials, how they behave, specifically around weldability. And I'm not one to say that additive is just an automated welding process. We all know it's more complicated than that. But to be able to fundamentally know kind of the metallurgy and what happens during a weld process has lent itself to, I would say, easier adoption and a lot more success than I think previously we thought was going to happen.
Yeah, that's interesting. Pitch it as a new welding technology, not as not as 3D printing.
Right.
Okay, interesting. I want to talk a bit about applications as well, and then we'll maybe double click again on qualification. So You made a really good point. The parts that are currently being printed are not, these beautifully generative design additive applications. They're actually sometimes quite simple, bulky parts, but there's obviously a huge supply chain case to print them. Can you give us maybe an example of what type of applications, if you are able to talk about, you see, and also like what type of supply chain benefits are you seeing? Like, is it going from half a year to days? Like, what types of impacts are you witnessing?
Yeah, I have to be careful about the specific applications. I will say that again, because there was this top down, we're going to go do additive, it really opened up all parts from the most basic, handles and kick plates, very similar things that we saw the aerospace industry get started in, what we would consider low risk, in that it if that component broke, it didn't jeopardize the mission or didn't jeopardize lives. But we want to go all the way into sub-safe things that would be part of the structural hull and would have to be able to be battle tested and battle ready, which would, if that failed in an unexpected way, could result in failure of mission or failure of life. And that's really why the certification process is so exhaustive, is because, we always keep in the back of our mind that uh, we are fighting 60 plus years of knowledge in an incumbent manufacturing process that we've got to gain over a very short period of time, so that there's confidence that when I'm done with my build in an additive process, that I get the same kind of level of understanding and level of confidence in the performance of that part.
Gotcha. And I mean, I think you mentioned earlier, from what we know from other industries, from a material properties perspective, that shouldn't be an issue. It's probably more about the qualification aspect of that. How What does that process now look like for a let's take the example of a conventional supplier. Let's say they manufacture valves today, and they now want to get into or they want to integrate additive manufacturing into their process chain to be able to meet requirements and meet demands. How do they now get additive qualified for a Navy program?
Yeah, so there's a couple elements to that. One, right now we are successfully doing what I would consider pointwise qualification of parts. This is very common that we've seen in other industries, where in a one-off basis, even if I have some exceptions, I have the ability to print that part and to be able to install it on a boat, whether that's submarine or surface. But it doesn't completely open up necessarily that family of parts. You mentioned valves. It doesn't open necessarily up for all geometries of all part criticalities. So we can do this one for one replacement, and we've seen, huge savings on the in-service side from a time perspective. We recognize that in a lot of cases, we've got parts that we just don't have a long list of inventory for, and we don't have the ability to manufacture them, because you're basically going to disrupt new construction to be able to support on the in-service side. So additive in this case has saved, on the order of months, I would say, in specific use cases where we've been able to take a broken component, maybe not the entire component, but a part that failed during a mission, and we're able to reverse engineer that in a matter of days, be able to get through some of the preliminary process development and get multiple versions of this printed, such that we can have one for installation, but are able to do some of the destructive testing to be able to gain kind of confidence in the performance of the part.
Wow. And to that point earlier, so the supply chain benefits of additive really are months and months of shorter lead time. What's the most extreme example you've seen?
I think we've got some data out there where, again, from a forgings and castings perspective, we could have something like 900 days delay, and it's not a consistent 900 days. It's the quality and the inspection process on the traditional manufacturing side that really kind of leaves us guessing. So it's not like I could just place a PO 18 months in advance and hope that they get through kind of the trials and tribulations. So I can't just buy my way out of this. Additive, again, really allows us to kind of come in and to be able to say, hey, even if I have to print it a handful of times, we know the print times versus the casting process is orders of magnitude reduced.
Interesting. I mean, and I could see many benefits of this program for the broader manufacturing industry in the US, right? I think it's putting additive on the map for very traditional manufacturers out there, and really forces them to rethink maybe what they've heard 10 years ago about this technology and its readiness. So I could see a lot of positive ripple effects throughout manufacturing, also for other industries, from some of those initiatives. One of them also being workforce development. It's hard enough to get people into manufacturing. Maybe it's not as hard to get people into additive manufacturing. I actually don't know. I think one of the things that additive may be able to do is, and I think you said this yourself, right, is to make manufacturing a bit more sexy again versus just computer science, and I want to be in tech.
Yeah.
I don't know if you share those thoughts or not, but what is your point of view on the current gap in the manufacturing workforce? Is it as bad as people say? How difficult is it currently for MIP suppliers to attract talent? And especially, how difficult is it to get talent that is familiar with additive and kind of can hit the ground running?
Yeah, I would say our latest count is something on the order of 250,000 employees that are needed to meet the demand. I think that's over either a 6 or a 10-year window, depending on who you talk to. I was smiling because you made me think, in my opinion, who wouldn't want to grow a submarine? I mean, that was how I got into it in the aerospace world was, hey, go print me an aircraft. And so that idea is very different. Not that we don't still need the welders, machinists. We still need NDTers. We still need operators. And in some case, additive makes that worse because it comes with additive as well, right? You still have to have those, but it's foundationally built around a technology that's growing and is transferable outside of the Navy, right? So I talked before about the modernization of forging and castings. It's not as much incentive to be able to do that because where else can I apply it and how can I grow? Maybe as a small business, how can I grow my portfolio? Additive, on the other hand, we know is so flexible and has the ability to lean into other areas and diversify my offering to multiple industries. So I believe that technology in general, not just additive, even some of the Industry 4.0 type initiatives that we've set out to do, bringing in automation and robotics, all of that should be a recruiting tool to the next generation of makers and doers.
Totally agree. Totally agree. And yeah, I think advanced manufacturing technologies are even somewhat nowadays, they are on the interface of some of those verticals, right? If I'm an additive engineer, oftentimes I need to be a material scientist, even I need to be even a software engineer a bit, because I could even code my way out of a certain problem. So it really is an awesome combination of disciplines that, from a career perspective and a career development, I think is and should be very interesting to mechanical engineers or even also industrial engineers out there that are trying to figure out, where do I go with my career, or even after high school, and going down the technician route for additive or technologies like that.
Yeah, I think you're hitting on a great point. It's not just one discipline that you have to be familiar with. And I think back to a tour that I did in the University of Minnesota. They created a program called the Da Vinci degree, and it really tied in to so many different disciplines that usually don't interface. So you have the mechanical side. Obviously, we have moving parts and we have to be able to structurally analyze what we're producing, but there's a huge material component of that. There is a huge software element in which starts to bring in AI and some of these other sexier tools. And there's also and at some point there's an artistic element. So you're hitting on maybe multiple lights that someone like myself wouldn't fit into maybe just a traditional standard mechanical engineering path. I like all these other areas. And so how does that come together? Additive really is at the center of all of those disciplines.
Yeah. And what a cool name, Da Vinci program.
Yeah, who
Who
wouldn't want
doesn't
that
want to be
degree?
yeah, exactly. A master's degree in Da Vinci. You touched on a topic, wouldn't be a podcast if we don't talk about AI. I could see a big challenge of the 2+1 strategy is also deciding what do we do additive, what do we do conventional, how do we ensure that our conventional suppliers focus on programs that actually can't be manufactured any other way, not even additive, because submarines are pretty big
Pretty
and
big.
additive does have certain size limitations. And this now leads me to a 2-point question. One is how does the U.S. Navy or even suppliers themselves decide what is going to be an additive program? Is that pure lead time? Is that also materials and certain capabilities? And then the second part of that question is, are there certain tools, for example, AI tools that can accelerate the decision-making process, can simplify supply chains, select certain suppliers, etc.?
Yeah, I'll start on the first. So we all know who've been in the additive industry that there are just some geometries and configurations that it just doesn't make sense. And so why just because I can print it doesn't mean that I should in a lot of cases. And I think that has to do again with anticipated yields and making sure that I'm not making the problem worse when it comes to trying to throw something at this technology that it's just not geared for or really is not a good fit. So there is an evaluation of parts that are on the critical parts list or are part of the critical materials path, let's say. You still have to have one extra layer of filter to be able to analyze those parts and to be able to determine, hey, is this a good fit for additive? And so there's a lot of time, walking around the shipyards and doing that manually. I think there's a huge opportunity in, leveraging some type of scanning capability that through some, basic checkpoints to be able to say, hey, I think these candidates make the most sense. And maybe there's a human in the loop that allows you to validate that. But I think just the sheer volume of parts that we're trying to sort through manually, I think there's definitely an opportunity to be able to kind of streamline that when we get to more of a steady state.
For sure. And the technology is evolving so rapidly. There may even be some tools out there soon that lend themselves really well to this program. Before we end, I have a few more questions. One is, now you've been in additive for a while. You've now also been part of the BlueForge team for a while. What type of technology maturity have you now already witnessed? I think, at least from where I'm sitting, today's discussion about additive capabilities and costs and material availability is a very different conversation than even 2 years ago. What has been your perspective on how far we've come already in hitting some of those demand signals?
Yeah, I think there's so many elements to that. First off, I just think the reliability and industrialization of the printers has made a huge leap from where it was 10 years ago. And so 10 years ago, the conversation would look very different. It would be, is the reliability there? Do I have all of the checks and balances that you would see in a standard kind of traditional manufacturing process? And I think we've been able to answer that now 10 years later. I think the second piece of that too, and I'd gone through one of the first FAA qualifications of an additive material, and it took 10 years to really make sure that we were analyzing the right variables. There's so much. If we think about the additive process, I'm basically making the material as I go, as I make my part, right? And so if you think about that, there's a lot of things that are drivers in quality and drivers in performance, but there's also a lot that I can get kind of hung up in and confused about. So my DOE or my ability to generate allowables, for example, could be massive and through the roof. And we've had to have a couple kind of pioneers sort out what is important to look at and what are the key variables to really modulate and to be able to understand what happens when I modulate that from a statistics standpoint. And in some cases, having to invent new statistics to account for that was part of that kind of pre 10 years ago journey, where now the Navy, who has their own kind of qualification processes that might be different than, say, MMPDS, but they're all trying to get after the same thing. What is it? Is confidence within a processing window that at the end of the day, the part is going to perform how I want it to, or how it's intended to perform. So we've come a long way where if again, I kind of reference that first FAA certification qualification, that really took a lot of different perspectives to come together in one room and say, this is how we're going to do it. And let's just test everything in a lot of cases. And we've got a lot smarter. And this is another area that even AI could help with us, is selecting the right variables to modulate and to be able to get through those types of DOE studies as quick as possible. So in conversion or comparison to what the Navy is attempting to do, if it took the aerospace 10 years to do one material and process combination, we're trying to do 9 material and process combinations in 3 years, 3+ years, give or take. So there's a lot of learning that comes along with that. And I will say the Navy's at a bit of a disadvantage, again, from the materials that they leverage. They're very corrosion resistant and have different environments that nowhere else in any other industry other than shipbuilding do you really experience these materials. So we were starting from a point of, basically, I don't know if this material can run on this printer, to now I'm certifying it for class 1 sub-safe components.
Super cool. Yeah, I mean, and that it's a testament to the maturity of qualification processes of the systems, also on just material development capabilities and knowledge, and how we can ramp that up quickly as an industry, to also new technology developments that make the process faster and more stable. Yeah. Now, looking forward, right, over the next 2 to 3 years that you mentioned, what needs to be true? What needs to happen to keep the 1+2 mission on track? Are there certain KPIs and key points that cannot be missed in order to be successful?
Yeah, I alluded to previously this kind of hand-to-hand combat, this point-to-point solution. What we're trying to get to is what we call interchangeability, and that is going through the full life cycle of R&D, meaning I have to make sure the printer can make the part. Test and evaluation, so T&E, this is now where I start to bulk up with the statistics to have the confidence in it. Then I go through a qualification, which involves vendor qualification, machine qualification, by material and process combination. And then the last piece is I've got all of the other ancillary elements kind of sorted through, and specifically on non-destructive tests, we still have to inspect. We have to do first article. We still have to inspect all of these parts in a non-destructive manner. And so we've looked at all of those things in the value chain and really are creating either specifications or what we call peculiar project documents that support the end-to-end workflow, such that, again, you can distribute that out into the supply chain and are able to have confidence that if a vendor on the West Coast is producing this component following these instructions, a vendor on the East Coast will get the same result. And that really, to me, is the crux of opening up the full aperture and opportunities for additive, is to come through what we call these material maturity efforts, such that we can say it is interchangeable with how I've traditionally done it, whether that be forging, casting, or machining.
Awesome. Yeah, very, very crucial step. Now, thinking about the listeners out there, what's your call to action if you're either already a supplier to the MIP but not an additive, if you're somebody who wants to get into additive but doesn't know how and doesn't know if it's the right move? Like, what do you want people to know and push for when it comes to supporting BlueForge Alliance and the MIB to get this program done?
Yeah, I would say there's a couple things that I would send out. First off, we are very much a partner first model. We really want to grow the network, and we want to know about your capabilities. We want to be able to know where you're wanting to go, and we've got, again, either through the AMCOE as our first entry point into the Navy for everything additive. You've got a lot of people there that are able to help kind of work through, depending on what perspective you come from, right? I do shipbuilding now, but I want to incorporate additive, or hey, I do additive and I really want to offer up my capabilities and some new capacity to shipbuilding. We've worked through both of those scenarios, and I think that's a great landing spot. In general, when I talk about the things that are complementary to just the printer itself, I alluded to the fact that we're going to need machinists, we're going to need NDT houses, or non-destructive test houses with certified technicians to be able to do that. That's all part of the value chain. And, you can reach out to us at blueforgealliance.us. We also have a recruiting tool called buildsubmarines.com. So if you're someone who, as an individual listening to this, wants to be able to get into additive and into supporting the Navy's mission, Build Subs has the ability for you to be able to create your own profile, and it's a platform powered by ZipRecruiter, where we can start matchmaking your needs, what you want to do with your career, and all of the just overwhelming opening that are out there in the industrial base. So I think we've done a good job of being able to create common and simple entry points. And I would definitely, have you all reach out to us directly. There's a form that's technology specific on BlueForge's website, as well as the AMCOE, who can really get you through and hold your hand through all of the many steps to be qualified and stood up as an approved vendor by the shipbuilder.
Awesome. I didn't know that platform was even integrated with ZipRecruiter. That's super cool.
Yeah, it's pretty nifty.
Call to action from my side. There's also a joint program between BlueForge and the Additive Minds Academy, available to MIB suppliers. So anyone who is part of the Maritime Industrial Base to get a fully sponsored training for additive manufacturing. So from data preparation all the way through machine operation, all funded. That training happens in Michigan. We'll put the link into the show notes and into the posts. If you are a MIB supplier, there's a fully funded training program for you to either get existing team members on board for additive, or to check out how does the additive manufacturing process chain really work and what does that mean for me if I want to integrate it into my operations.
Yeah, nice.
Chris, it was awesome to have you on the show. I learned a lot. I need to also dive a bit deeper into those two submarine classes and learn more about them. Awesome work you guys are doing. I really appreciate you guys also being that connection point to the Navy, especially for us in the additive manufacturing industry. And of course, all the work that you're doing personally. Very much appreciated. And thanks for sharing your insights with us today.
Absolutely. Thanks for the time, and always a pleasure to work with you, Fabian.
Same here. And also thank you out there for tuning in today. If you enjoyed this episode and conversation as much as I did, feel free to share it with any friends, especially if you have friends in the Navy ecosystem. I'm sure they should be able to learn a lot from Chris and what we talked about today. Also, feel free to give us a review or shoot us a message either in YouTube or on any of the social media posts if you have any questions for Chris or myself. This was the Additive podcast, and I will hear you next time.